Hello, can you tell me a bit about your internship?
Sure, my name is Bryanna Erickson, and I interned at Duke University this last summer. My work had two main parts. First, I developed and extended autograders, the systems that automatically evaluate student programming assignments. These graders don't just check correctness, they also provide feedback, so they are an essential part of the learning experience. Second, I analyzed learner data from Coursera to better understand how students engage with different kinds of assignments like closed-ended versus open-ended tasks.
Oh, that's pretty cool. What kind of technical work did you do day to day?
A big part of my technical work was actually building the autograders themselves. That meant writing grading logic that could handle edge cases, structuring test suites so student code was evaluated fairly, and ensuring that graders gave useful feedback instead of just, hey, you got this right or you got this wrong. Alongside that, I worked in Python and SQL to analyze student submissions and survey responses. The two parts tied together nicely. The autograders actually generated this data, and then my analysis helped us see how students interacted with those graders and those assignments.
Wow, that's pretty technical. What's the most important technical thing you learned?
The most important technical lesson was learning how to design reliable and reproducible systems. With the autograders, reliability was everything. If a grader failed unpredictably, it could block tons of students. I learned how to carefully test grading pipelines, anticipate weird edge cases in student code, and document design decisions so graders could be maintained for more long term.
Wow, okay, that's pretty cool. And what about some non-technical skills? What was the most important thing you learned there?
Definitely communication. I had to collaborate with researchers, instructors, and developers, and each group cared about different things. For example, the developer side wanted technical details of how the autograders were structured and how they were working, while the instructor and research side wanted to know how these students were responding to these autograders and how they were responding to the assignments. So I had to learn how to tailor my explanation to the audience, sometimes going deeper into code design rather than just for other groups, summarizing the big picture of results. That skill was just important as the technical work itself.
Wow. So, that sounds pretty hard. What's the most proud achievement or accomplishment you had?
I'm most proud of the autograders that I developed. Some of the graders I built are going to be deployed in the actual Coursera course for Duke, which means students are going to be directly impacted by my work. Knowing that my code made the learning experience hopefully smoother, more reliable, and more fair for students around the world, what feels incredibly rewarding. I'm also proud of my analysis showing differences in how students approach closed versus open-ended tasks, because it gave my team concrete insights to guide future course design.
Wow. Okay, so to wrap it up, let me ask you two extra questions. First, what surprised you most about the experience?
I was surprised by just how much iteration is required when developing something like an autograder. It's easy to think just write a test suite and you're done, but in reality, students submit code in all sorts of unexpected ways. I had to keep refining the graders to handle those edge cases without being too strict or too lenient, and that process definitely taught me patience and importance of thorough testing.
Wow, that sounds pretty hard. That sounds like such a learning experience. How will you apply what you learned moving forward?
The skills I gained both in developing reliable systems like autograders and in analyzing data are skills I will use everywhere. In future coursework, I'll bring a stronger focus on building things that are reproducible and maintainable. Long term, I know these experiences will be valued since I want to work in CS education. Knowing how education tools work and how they are developed to enhance education will be very valuable for me. With this experience, I also have a bit of knowledge now about grad school and what to expect when applying, learning all of this from grad students themselves and professors.
Wow, thank you for sharing all that. Do you have anything else you want to add?
Thank you. It was a great experience, and I'm really proud of what I was able to contribute. I also want to say a quick thank you to Berea College, my mentors, Dr. Kristen Stephen Martinez, Dr. Susan Rogers, Professor Yesenia Velasco, and Xiao Henko, and my peers as well, Abby Melton and Jerry Zhao. Thank you.